All right, good afternoon and welcome to our session today, Managing Learning series. This one is how to build your data science team. We're going to look at a number of uh, issues as well as recommendations around what that means as far as a proper data science team today. So who are the players, what do they do, those kinds of aspects. We're going to discuss, why this area is so hot at the moment, and how long will it be hot. And we're also going to look in particular at technologies that data scientists and data engineers might use. We'll talk a little bit about Python and PySpark. We'll get into AWS. We'll see how to set up AWS instances, those kinds of things. And we'll also talk about serverless technology today. I have a demo both around the worlds of PySpark and data science, as well as in AWS. We will generate a serverless application through AWS CDK. We'll use AWS Glue to basically build the infrastructure for the data that we're going to work with. We'll query it with Athena, and then finally we'll look at some visualizations with tools like QuickSight. Of course, there's others that we'll talk about as we go along, and various pieces of interest that people will probably have towards the end, which will open up to questions in particular. So again, welcome aboard. My name is Kevin Clements, and I've been working in this field and teaching for a number of years, in fact, over 25. I am president of Claremont Communications and 3XD in Ottawa, Ontario, Canada, and we develop information technology products as well as work in the cloud. We've been an AWS partner since 2007, a Microsoft partner since 1995, and a Google Cloud partner since 2013. What do? We do control systems. So in my environment, we spend an awful lot of time with little sensors like this that are picking up data and reporting back to us, or these kinds of sensors, fire alarms, and those kinds of things that are sitting in a building structure. We record about 500 gigs of data per floor in a building on a monthly basis, and of course our analysis that's required for that is to predict problems, whether it's with the lighting system, the heating system, the cooling system. Because to replace a chiller on the top of a building that's a 50-story tower is not a cheap endeavor, and of course can take a considerable amount of time, so planning is required. But also those systems need to be integrated today. So not only are we collecting data, but we're using other technologies to ensure that that data is being reported to us in real time, streaming through things like Kafka. Of course, storing the data in the cloud. And today we have about around 35 exabytes of data on 150 servers worldwide, where we collect that information and analyze it. All right, so why are you here? What is really going on out there that's making the demand for jobs today in these areas so high? In fact, how high? Well, if you start looking around for reports, you're going to find that 11.5 million jobs are going to be available in the data science field by 2026. Folks, I will share these links as well as share with you, of course, as the day goes on, some additional materials. This is the first one. This is from the Economic Times. And again, if you read through the article, you're going to find that the evolution of data science here has really pushed the requirements today for what a data scientist is, and sort of how you move into those job roles, the concepts behind that, and so on. Data scientist, well, that's somebody that basically has a sexy job today, according to at least the Harvard Business Review. They're saying that when we start to learn a lot of these technologies, we can utilize them in different ways. It's not just Excel with a CSV file anymore. There's a lot more to it. And that's a requirement for learning as well. And once we realize the various pieces that fit in here, things like simple algorithms, machine learning, right, AI, all of those top areas that we're hearing about today that are in demand. So again, this is another one of those backgrounders that I like to share out here at class for folks to be able to have a little bit of information about what's happening there. But this is probably by far the biggest factor today. If we think about 11.5 million jobs, that's a huge amount of jobs in this field alone that will be available in the coming years. And whether you're a manager who is trying to fill those roles, or whether you're somebody within the organization that is already in a role similar and wants to move into those roles, then to understand what that's about, that's really what we're talking about here today. Now, we break it down into two areas, in particular in this seminar. We're going to be looking at data scientists and data engineers, and we'll concentrate on those areas in particular. But you'll notice here on the slide, there's additional folks that fit around those roles, and some of them are supportive roles, some of them are peer roles, and of course others are complementary roles that are assisting in some manner in analyzing the data, or at least fleshing out the requirements for the data to be analyzed. So if you think about business analyst and business intelligence analysts, those are two different roles, of course, and both of them are complementary and supporting roles that the data scientist or the data engineer will work with to ensure that data is prepared and ready. So again, a lot of keywords that we'll hear throughout these sessions are typically ETL or ELT, extract, load, transform, or extract, transform, and load. We'll talk about instances where both of those are valid. In particular today, if you're moving data at a high streaming rate, you may want to do the ELT approach, where you are loading that and then transforming it somehow, just because of the rapidness of that data. Or you might want to take Kafka's approach, Apache Kafka's approach, and put the T in the transform inside of the queue, where you can make changes to the data as it's being sent through the data stream. So there are different approaches here, obviously. Still need our software engineer, because they're going to probably do something with the data to help prove that data or use it in some kind of application. And of course, the project manager hat that we always have available here, those roles are all going to be important. So what are we thinking about then as far as what the roles and responsibilities are, and can we clearly articulate those in some manner? Now, these areas are often quite gray when it comes to data scientist, data engineer. And in fact, whether you're a data scientist or whether you're a data engineer, often you're doing similar roles, but there's an expectation for specific areas of requirement for the data scientist, as we'll see here. So you'll notice the first thing it says is knowledge and skill set. So we're thinking about what do you need to have as prerequisites to essentially become a data scientist today. And we've got a few, of course, pieces of information for you, and you can see some of the very tags there that list things like artificial intelligence and data analyst and data engineer. Really what they're talking about is learning the pieces that allow you to take on those roles. Or if you're the manager, you're going to be looking for people who have these skill sets. And we'll talk about those skill sets in more detail momentarily. Again, another great article here for you, and as I always do, I share those in the chat if you want to follow along. This follows with the Harvard one that I showed a few minutes ago, and talks really about what that term means. And if you think about the term, 10 years ago, we were talking about servers that were on-prem, that were maintained typically by the organization. Today, there's a separation of concerns, and that responsibility has shifted, and doesn't mean that the responsibility for the security of the data has shifted, but certainly the responsibility has shifted as more and more organizations are working in the cloud. And as I said, we're going to take a jump in particular look at in this session AWS, but I will compare the AWS to Microsoft and Google, so you'll get an idea across those three platforms what the expectations are today for tools that you need to be aware of. So again, discuss those as we go on. Good article here. So some of the skill sets, I'll go over those in more detail in a moment here, but you can see, again, according to Insight, this is basically some of those key areas that we will mention momentarily here, and the various pieces that fit in. We also have one at WebAge that we'll share with you towards sort of the middle of the class here that you can use for your own purposes as well. We've got the computer science idea, we've got statistics, and we've got mathematics. Now, how much of that is going to depend on the role of the actual data scientist. Remember, even within the naming here, there could be different pieces that the data scientist is doing. But the idea of having access to the various tools and of course, knowing the techniques to apply to data, that's a critical piece. And that means proper training, proper understanding of the techniques that are available. We're not just going to use Bayesian all of the time. We're going to pick some other type of model or algorithm and apply it to our data, dependent on, of course, the outcome that we're looking for within that data set. And of course, as I mentioned a moment ago, it's keeping up with those trends. So we're still doing on-prem stuff. We're probably still using some SaaS somewhere out there. We're probably still working on our SQL knowledge, right? Building out our, our larger cubes. I always, make a joke about that by holding up my Rubik's Cube, right? So we're working on our cubes out there, analyzing data over time, which is typically the way we do in a cube, and roll that data up in SQL. But there's a lot more to this. It's not just using those traditional ways and methods of exploring data. Today, we've added in sort of the next level with the ability of going out to the cloud, generating in a matter of minutes, new instances that can handle, if you think about this, 1 million IOPS is nothing today. We can take that so much higher as far as the ability to process the data when we move to cloud, and we take advantage of course, the costing out there. There's a wonderful example that the New York Times did a few years ago, where they wanted to take their 49,000 papers that have been produced over a century, and they wanted to digitize basically all of those pages so that they could present them as a library that could be searched. And of course, that meant transforming images into something that was OCR'd, or optical character recognized images that then could be searched and tagged. They figured it would take about 300 machines and somewhere around 10,000 hours for those 300 machines to process that amount of data. They went to the cloud, and of course, AWS in this case, used AWS for a cost and a total time of just over a day, about $290, and that's US dollars. So you can see that there are efficiencies that can be gained by taking advantage of these new environments in the cloud in particular. One of the things that comes up, and one of the things that both data scientists and data engineers need to be aware of course, is security. Now, we could cover a whole course on security, but let's go with the old rule here. When you move data in motion, needs to be encrypted. And when you're storing data, right, we need to impose proper security around that, whether it is imposed on us with regulations like FedRAMP, Sarbanes-Oxley, or some other regulation out there, FIPS perhaps. That could be an organizational thing, but there should be at least a minimal idea that we're encrypting data at rest as well, right? Policies, those kinds of things would need to be looked at on a case-by-case basis with the data that you're working with. Again, whether it's working with that small raw file, maybe it's a CSV file, maybe it's a web log of some sort, we want to get that as quickly as possible from our on-prem device into the cloud to do further analysis. Again, this is the trend, right? Moving everything to the cloud. Now, it doesn't mean that everything will, so the data scientists will still need those skill sets on both sides, as we mentioned before, in order to work with these kinds of scenarios. And whether it's a smart device like a monitor that can pick up motion, or whether it's social media or other data sets, they have to be comfortable with data that is not schema based, right? So we haven't created a table and we haven't set out the names of the columns yet. We may do that, and we may automate that process in some manner today, especially with larger jobs, and that's more likely, in fact. But the data sets that we're working with are often not in any form that can be utilized directly in an SQL database. So what do? Well, there's lots of solutions, as you're probably aware, and you probably heard the term NoSQL, not only SQL, meaning that we're still going to keep our SQL databases around, our transactional, and of course our data warehouses, but at some point we may need to adopt additional tools that we can utilize for storing and manipulating the data. Big one, of course, HDFS, or Hadoop as it's known, allows you to store things or records as essentially file folders, much like the file folder on your machine that you're probably watching with me right now, right? The laptop or the desktop, whichever might be the case. Even your phone today, whether it's Android or Apple, has some kind of hierarchical file system on it. And that terminology goes back to the 1960s, well before the discovery of and the setup of relational databases with EF COD and the team originally at IBM building out System R in the 1970s. Skill sets, knowledge, and here's the last one: some kind of research ability. Some kind of research ability. That's an important piece. We want to look for somebody that's not afraid to take the information coming in and trying to interpret that result. Research further to get a clearer understanding of how it integrates with the system that they have, talking to the business intelligence analyst or business analyst to figure out where this fits in, but also looking at, of course, additional information, whether it be the social sciences that you want to bring in, or whether it be technology-based, web servers, those kinds of things that you're trying to track. We need to find some common ground around the information that we're working with. And essentially, that's the role of the data scientist, to identify those pieces that may be extraneous and figure out a way to take those extraneous results and bring them back into the fold so that we have a clearer understanding. Now, you'll hear a lot of terminology around this, a lot of it from the world of data science. One of the big ones that a lot of people will talk about, at least today, as far as a tool for doing this, is Python. It's not the only language out there, but it certainly is a big one when it comes to doing that. And why are they talking about Python? What's the big deal here? Well, the big deal is that Python has a number of packages that are already available for us to work from as a data scientist. So you can see here, this is a machine learning package in Python. It's complementary to something else that you may have heard, and we'll see a little bit later on a demo of that, which is something called pandas. Why scikit-learn? Well, as you can see, they've taken the algorithms and simply grouped them in a way that they can be applied against data sets. And here's some great examples, as you can see, of utilizing that information. Imagine you're Amazon and you want to figure out whether somebody who is on your site at this moment is going to buy a product. How can we be assured when they do a search that they're going to buy the product? There's a lot of things that we can use here that will help us. First one is the idea of clustering. So we can look at comparable people that we know, right, that are very similar in different qualities to the person that's currently logged in, and we can start to figure out whether that person has similar habits or trends to others. And of course, we call that clustering, often done with something like k-means clustering. There's others as well, but clustering means figuring out whether you fit into one of these areas. And if you do, then what do we need to put in front of you to make you buy something? And it's not just Amazon. It could be your Walmart. It could be the drugstore. It could be anything today, right? This is pretty much what most of them are using. There's another way of doing that as well, and that's looking at this idea of classification. So data scientists need to know these various pieces so that they can take those and apply them to different operations. This whole area, data science, stemmed from the idea of doing fraud detection in banks, but it's gone a lot further today. We still have the ability to do things like fraud detection, but now we have the ability to look at information in real time and make immediate predictions about information that we're receiving. And some of these algorithms are basically around that. My favorite is regression. I use it about every sort of 5 years to figure out, what's the trend in my neighborhood? Is the housing prices going up, going down? And we can use this as a way of basically figuring that out. Now, I don't know about you, but that math would absolutely drive me crazy. The good thing is, if you've studied statistics, if you studied mathematics, probably means a lot to you already. But if you haven't, how can I take that same information and apply it as a data scientist or as a programmer? Because often those roles come together at some point. Somebody from the programming environment moves into the data science world by learning additional pieces. How do I do that? Well, I use it, of course, with data, and I write some little programs around it. And you can see some examples here of being able to do that, right? Applying some kind of real world example to the data that we might be working with. And somewhere, right, out of that, we're going to be able to get that line that will show us whether the housing prices are going to increase or decrease in the neighborhood in the coming years. And that's really the thing that we're interested in, right? The requirement is to predict that, but predict it so that we are not struggling, right, and trying to lose money or trying to move, in a very short period of time because something in the area has changed. So again, I'm going to bring up that and put that in there for you to look at. And in fact, I have a little bit of an example, a couple of examples actually that I've prepared for you. This is the cloud community at Databricks, and I just wanted to show you what a typical data scientist might do with some kind of data that they receive. And we're just going to work with some simple data sets here for the examples. We could obviously go into a lot more detail, but again, from a manager's point of view, what is it that I'm expecting these people to have the capability of doing? So I've brought in this thing called Data Science Team, and what I've done is I've actually imported some data here, which you'll see came from simple URL, it's basically cars data. It's a standard data set that can be used for this kind of exploration. And you can see that I've imported a couple of libraries. Again, this is the Python language, so quite prevalent language to use for these kinds of analysis. We'll see some others examples as well, including JavaScript and TypeScript before the end of the course. And you can see here we are basically reading in a CSV file, and then I'm returning the first 4 records from the CSV file. That's what we see here. So a CSV file, you can see that there's different data types, and of course we've got columns and rows, a table structure, right? That is typical of a CSV, even though it's not really columns and rows in the sense of the structure that we might have for a relational database. But even so, by using some of the additional tools that are available in Python, like Matplotlib and Seaborn, I can take that data and do some kind of a plot with it. So here we've got sort of that concept of basically working with horsepower, and of course, one of the other dimensions here, right, is weight of the vehicle, and we can plot out, how much horsepower do you need to move a vehicle of a certain weight, right? What's the optimum area? So we see that the optimum here is roughly between 100 and 200 horsepower, and this is, again, 2,000 to 4,000, and again, that's in pounds. So you can see optimally it's somewhere around maybe 27 to maybe 37. Now we could, of course, increase the plotting that we're doing here and get a clearer picture of that actual result of where most of the engines and the weight of the vehicles fall in that data store that we're using here. But that's kind of the idea. We want to do a plot of it, graphically show me, visualize to me what that data that I'm working with means. And again, that's a typical role of a data science team working away on some kind of analysis of that data that then can be turned back to the organization. And if I was, Ford or GM or one of the foreign manufacturers, right, I would be looking at this and saying, well, most of the cars are fitting around this. They're getting away with 4 cylinders. Maybe what I could do is I could put a turbo on my engine, and I can get more power, and maybe the consumer would buy it, right? There's all kinds of scenarios. Or I can say, maybe we should be looking at building electric vehicles because all of these ones here are gas. And I think that's probably what Elon and his group did. But that's a whole other story, right? Again, there's lots of things that we can do with this, and you'll see here some of the language behind it. So the ability to make directories to store data in, and sort of what we've done here in this example is basically stored the data. We can look at data that's already existing in the data store. We can see the size of that. So in this environment, I'm actually working with a clustered environment where there's more than one machine that's doing the operation in the background for me. These are memory-heavy machines that have been set up, so meaning that they have lots of memory, typically between 256 and 512 gig of memory. And so when we start to do our analysis, we're taking advantage of storing the data in memory almost right from the get-go. We might use something like Spark, which is an in-memory data store. We might use something like Redis, which is a key value in memory store. There's all kinds of choices here depending on what we would work with. And again, we'll take a look at some of that information shortly here in our lecture. Again, taking a look at the data set, just asking, well, show me what the first couple of rows look like. Store a new data set. So again, the ability to perhaps make changes to the data, which we often do in EDA, right? Exploratory data analysis. And of course, across the board, whether you're a data engineer or a data scientist, you're going to do some kind of ETL, or extract, transform, load of that data. So that's exactly what we're doing here. We're extracting some data from previous, and we're loading it into a new table, which we're going to call cars. And you can see that has been stored here. And then what can we do with it? Well, we could start to read information from it. So we can look at the various columns that are in that data store. We can look at the data types that are associated with that. Perhaps, things like miles per gallon and horsepower shouldn't be string data. Perhaps that data should be modified in some way to conform to the types that are there. Maybe we want integers or big integers or something like that, again, depending on the size of the data. So we would change the data types to essentially work with the type of data that we need, and then we can apply our plotting and so on so that it's more accurate. It gives us a better operation of doing that. And you can see down here, this is the idea of basically recreating that information. What we've done is we've actually stored it into essentially a Spark data frame. If you think about an SQL database, you create tables, and those tables are stored on the hard drive. Okay, so they actually get stored on the hard drive, all of the data. In order to work with it in SQL, we have to have a very expensive machine in order to call that data, bring it to the expensive machine, put it in memory, and work with it. We always try to work with as much data as possible in memory. It's faster than I/O operations that we would have. Spark itself, as I mentioned earlier, is an in-memory data store. A data frame is essentially a table in memory. So about equivalent to SQL. Here's the difference though. Spark's about 100 times faster in performance than SQL. So there's the advantage, right? What took forever to do a report in SQL takes barely a few minutes, especially in a larger clustered system where we have multiple machines that we can run that on at the same time in parallel. This gives us higher level performance, 100 times faster typically. And this is one of the advantages. So as a manager today, right, if we need to get information in a faster way, we need to look at newer ways of doing that beyond what SQL could do for us previous. We're not throwing away SQL, as I said, but what we're probably doing is building data portals now. And you've probably heard that term. When we get to the data engineer, I'll talk more about that. But essentially, a data portal allows us to take the best of both worlds. Our idea, right, of the data itself from SQL and our data warehouse. But the data warehouse data and the SQL data cannot be brought together directly because we've removed the commonality. Right? We've denormalized the data set, put in repeated information as opposed to separate tables. And that means that we have to have some way of bringing that back together. So today what happens in most cases is the data warehouse data is moved into something like Hadoop on-prem, or in the cloud, we could use EMR, or into something like an S3 bucket, which is essentially Hadoop in the cloud. And then we can use tools like Hive to allow folks that know SQL, the data scientists and others, to perform those joins that are so critical between our old data, right? Things that have been put into our cubes, as we mentioned a few minutes ago, and bring that together in the data portal with our live data. And there's lots of cases of that going on here in Canada, where I am. We've got the CRA doing a lot of that work. Down in the US, IRS. There's other federal agencies that are trying to amalgamate that in some way, whether it is in the GovCloud or whether it is private industry doing it, like the insurance industry or others, which we've seen a great example of recently. I've taught a number of courses in those areas. All right, so here's some of the other things that we can do with it. So let's show the data. Now you can see that we've transformed the data, right? It's no longer string data. It actually is data that we can do some comprehensive understanding of, whether it's floating point data or integer data. And of course, that's going to depend on the column, miles per gallon, cylinders, displacement, horsepower, again, all kinds of other information available to us. What can we do with it? Well, we can basically use that as an inferred schema to allow us to create those data fields and then, of course, read the data that we may want. And of course, from here, we could start to do similar to what we did above, chart that information out in some way. I have a second example that I'll talk about in a moment from this. But again, the data scientist is taking on this as a way of showing information to whoever has asked for it. Now, again, it could be managers, it could be business analysts, it could be business intelligence analysts, but somebody that wants that data and needs it now. But the data scientist generally doesn't work alone. And this is the second part of that team that we mentioned that's higher up there, and that's the data engineer. And we start to look at the roles and responsibilities. You'll notice that this one mentions a lot about programming, more so than the data scientist. But on par, they are probably doing similar roles when it comes to the preparation of data, the EDA, the ELT, the ETL, whichever flavor it may be. Here, what we want, though, is not to have it do it singular. We want to do it repeatedly. So the idea is a proficient program that's able to automate the process for us, most likely using some script language, whether it's Python or whether it's TypeScript. I suppose today it still could be Java and C++, right? All of those languages are still there for us. Perhaps Scala or even Go today, again, depending on the organization. I would say more prevalent in both cases is going to be something like Python and TypeScript or JavaScript, simply because of the tools that are available to us to work from. But that's not to say that there isn't others in particular that we might be looking at. So we'll take a look at those momentarily here as well. The idea is they have to understand what we call the different data stores. And notice we use the word data store here, not database, because a data store, that includes everything in what we now call our data lake, right? Our data lake, our large lake of data. And we've got so much of this going on today with different inputs coming in. There's a great graph around that, and I want to bring this one up for you. This is the IBM 4Vs. If you've ever been in a class with me, you've probably seen me share this many times. And really what this talks about is that changing data landscape, right? That data lake that we're mentioning. And that goes around things like, as you can see here, the volume or the scale of the data, which of course is increasing incredibly in a very short period of time, just because we're collecting more and more information. The velocity, that's the streaming of that, and it could be real-time data. The example there with the car, my chief developer, Gwyneth, drives a Tesla, and when she drives into her garage and turns the power off on the Tesla, immediately it connects to the network, which is in her home, and uploads all kinds of data about what she's just done with the car. And of course, they use it for predictive analysis, in particular here in Canada around braking systems, because there has been some issues with that. Not sure you care, but basically with the Tesla, once you take your foot off the pedal that is used for driving the DC engines, which are essentially on the wheels, they will automatically slow down, so you don't necessarily need to use your brakes, and as such, that's developed a problem with rusting. So that might be one of the things that the Tesla team is looking at, in particular, trying to understand how often braking is being done by the individual and whether this is something that needs to be serviced routinely, or more so, depending on that individual and the way that they drive. You'll notice variety. This is true of everything today. In my world, it's all about sensors, and sensors picking up motion and fire alarms and lighting and so on. But in other worlds, it might be Twitter feeds looking at sentiment, right? And gee, what do people think about our company today? Or it might be survey information or video or audio files that you're analyzing. Think about Netflix, who use AWS as their back end for storing and serving up movies, right? They use S3 buckets, which we'll again talk about shortly. Those S3 buckets, of course, are defined and set up by them, but that's not the only thing they do. They collect other information, right? Whether you give a thumbs up or a thumbs down to a movie or a television program that you've watched on Netflix, your history of what you've watched, other criteria that they're collecting to improve not only the performance of their system, but also improve satisfaction from the end users that are using it. And as it says there, Facebook, your own websites as well, where you might want to get that information and return it. Finally, it's the veracity, and that's that lake, because there's so many different pieces of data that we're dealing with today. Sometimes we're not confident in it, right? And the idea of the data scientist and the data engineer is to cleanse the data, to fix it, so that when we are looking at the final results of their output, we have confidence that that output is good data that we can work from. And again, there's a number of ways to cleanse data, do things like that. That would be part of the role of both the data engineer and the data scientist when it comes to that. We'll get into responsibilities here in a moment. I just wanted to bring you another report. This one is on the presence of data engineers today. You can see that there's been a demand increase, and this is an article from last February. And if you look quickly there, you'll see some other types of development in there. You'll also see a number of words around this one: Python, SQL, big data, Hadoop, ETL, all of those things that we're saying as being skill sets that are required by a data engineer. And then they throw in some additional pieces: Docker and Kubernetes. So now we're talking about microservices, small pieces of code that we can run and ensure that those continue to run using Kubernetes to monitor them. It's a monitoring service, essentially. So we've got a lot of this going on today, and a lot of information being used out there. Again, look at the growth of that year-over-year growth, 82%. Look at the year-over-year growth of Docker here at 42%, higher than anything else out there. So that's really what's happening out there. There's a huge change in the marketplace. There's a huge demand for data scientists and data engineers. And again, what are they responsible for from our data engineering point of view? You can see here on the slide, we're talking about maintenance and development of data pipelines. That's the movement of that data from the data lake to some kind of either unstructured, semi-structured, or structured data set. Now, what do we mean by that? Unstructured, that's going to be the raw data where we haven't done any processing. Semi-structured, we may have gone through and taken some of the data out, but not all of the data. And of course, structured is going to be back into the idea of SQL tables or some kind of implementation in the case of perhaps MongoDB, which is a document data store, or Cassandra, which is a column data store, where we're storing data in different ways than we have been in the past. Taking advantage, of course, of parallel processing and speed and performance of these new, NoSQL systems, whether they're on-prem or in the cloud. And again, it's that combination, as we said before, still looking at on-prem, but still keeping our eye on what's happening out there in the cloud as the trends continue to look like everything is moving that way, continually today. So building a pipeline. What is a pipeline? Well, a pipeline essentially is something that we're going to talk about coming up. We'll give an example in AWS. You'll see that we're going to use the CDK tool, and I'll talk about that. I'll show you how that's implemented and so on. But the idea is we're transforming data in some way. If you go back to the idea in Linux of pipelines, you might do something like PS-EF, where you're looking at all of the processes, and you might pipe that to grep and try to pick out one of the processes that you're interested in. Maybe it's your Apache server or your Nginx web server or something like that, right? So you're narrowing down the information, but you're moving it forward so that additional pieces can be done, or additional processing can be done on the data. And of course, it's that functionality, scalability, right, speed and reliability that we mentioned a moment ago in our slide from IBM that is very, very important for decision making. So when we turn this over to the project manager or the business analyst or the business intelligence analyst, for that matter, they have a good understanding. Now, here's where the data engineers and the data scientists differ, and it has to do with their knowledge requirements. And we saw in both of those items that I shared with you a while ago that there were some mention of different pieces that are required for the jobs. Well, that's what we're talking about here. Now, on the exploratory data analysis side, that's generally the data scientist. And that's taking some algorithms and other mechanisms that they can work with and applying it to the data, looking at it, figuring out what's there, and getting a good understanding. If we compare that to the data engineer, most times their work is extracting, transforming, loading, or the other way around, extract, load, transform, depending on, of course, the type of stream data that we're talking about here and what they need to do to it. It's not to say that those two things may be required in both areas. It's just more commonplace for data scientists to do EDA and for data engineers to do ETL, because the data engineer is going to prepare the data that the data scientist is generally going to explore. However, we're getting into gray areas now, and we often see both happening. And the reason is that the data engineer needs to be assured that the data that they moved was moved correctly. So they may need to know how to write an SQL statement, or may need to know how to run some kind of Python query or other language query against the data, and vice versa. The data scientist may be required to do some extraction of some part of the data, whether it is from the data warehouse, where they're taking the data out and putting it against the data portal, or maybe from Hadoop or some other data store that is a NoSQL data store, and amalgamating that with the SQL data. So these are the areas where it's often a gray between whose role is it to do that. You'll notice something on the next slide, which is very interesting, and that is, as far as the scripting goes, very similar, except that on the data engineering side, we put in two additional pieces, and that is Bash and PowerShell. And that's, of course, to accommodate the different server systems that the engineer may be working on. So knowing how to work with the Bash shell in Linux or in Mac, or knowing how to work with PowerShell, or both, it would be important. Today, of course, we can install Bash in a Windows 10 system. Can't do that necessarily on all Windows systems. So having some knowledge of PowerShell, can be important. You'll also see that I didn't put JavaScript there on the data engineer side. It's not very often that the data engineer needs to work with a front-end tool. And so that's more likely something the data scientist might need to do. For instance, they might use React or Angular as a way of looking at the client-side data itself, right, and manipulating it. So again, that's why JavaScript's there. And of course, JavaScript and TypeScript work together anyway. So there is an expectation that the data engineer would have some idea of how JavaScript works, since most TypeScript is transformed into JavaScript before it's run, transpiled as it's known. Below that, notice that the data scientist is concentrating on PySpark or Scala language. And of course, the data engineer is probably back there using the computer science stuff that they learned, right? As perhaps a computer scientist first, computer engineer maybe, software engineer maybe. So things like Java, C#, even C++, still quite common today when it comes to being utilized out there in organizations, especially with data heavy organizations. You know, think Pratt & Whitney, all of those organizations where C++ and embedded controllers are used. Things like that are pretty typical. Java and C# languages very, very similar to each other, not too hard to you know, to learn generally. Very similar context. Python, of course, is a little bit different in the way that it works. By the way, I teach all of those languages, so if you do have any questions at the end of the class around any of these materials, please do ask. I actually teach everything that's on both of these slides, so I can certainly walk you through any questions that you may have. Spark, Hadoop, MongoDB, Cassandra, those are all the NoSQL data stores that I was mentioning earlier. And you'll see the RDBMS with, of course, SQL there being foundational to the data scientist area. On the data engineer side, not requiring them to know Spark or Hadoop or Mongo or Cassandra, but definitely requiring them to know how to manage data formatting. Quite common to work with things like JSON, Parquet data, or CSV data. Now, just to give you a difference between those, JSON data has no schema. There's no official schema for JSON. Parquet does add a schema around JSON data, as does Avro. And of course, CSV, we're going way, way back. TSV could be, you know, tab separated or column separated data that we're working with, maybe from Excel or some other type of spreadsheet that you've used before. Going down to the next line, we've got visualizations here. So again, Tableau, a very huge product in the industry right now. Doesn't mean that we still can't use Excel, right? We've got Power Charts, we've got Power Tables, all of those things in Excel. And again, as I said, I teach those. We've got Power BI, which again is on the Microsoft side. A little bit harder because you definitely have to know how to write functions in Power BI, or at least a functional programming language. Whereas Tableau, and we will see QuickSight here in the course, I'll actually show that off, is more of a drag and drop. Once you've got the table data as measures and dimensions, right, then you can start working with that and dragging them to the appropriate layout in your charting that you want. Visualization on the data engineer side, more so to just check to make sure that they've got the data in play and, you know, they can read some data, kind of like we were showing there. What's the first 4 columns look like, you know, from the data set that I'm working with? And we, you know, saw kind of an example of that that I showed with our example here, where you know, you're going through it, right? And you want to see sort of what those columns look like. You want to see what types they are. You want to see the schema information, and then you want to have some kind of mechanism to you know, show that data. Now we could write the same thing directly in Python as well to do this. It doesn't have to be here in PySpark to perform, you know, the same kind of output. The idea, and I'll show you another example. This is one I created with data from Nebraska, and this is the COVID-19 data from February to December in Nebraska. and it shows a bunch of information. As you can see, the layout of the data is quite large. There is somewhere around 40 columns in the actual data set. And what I've done is I've downloaded it into my Databricks folder, and I've got this set up as Nebraska History -2 CSV. And you can see, the names of the columns. So I'm going to concentrate on date and death just to show the death toll over a certain period of time. This is again from sort of February to December of last year in Nebraska. All of the data sets that I'm showing, by the way, are freely open and available. Whether you go to a place like data.gov to get data, and again, these are recommendations that we generally make for folks. You'll notice here there's over 217,000 data sets that are available for folks at data.gov to work with, mostly from organizations. We could also look at open data sets as well in other areas. So for instance, open.canada.ca is the site for open data in Canada. So if you were interested in open data from Canada, that would be here, and you could again look at the data sets that are here. Probably going to be a little less than what you would find from data.gov, simply because there tends to be a tendency to generate more data in the US since there's more states and more people, obviously. We could look at the European Union. I can never remember what it's called. It's like Euro something. There it is, Euro. There it is. So there's their open data sites. And again, why work with open data? Well, your data scientist has to get trained in some way. And if they can work with data sets like this and then take that data and apply it to your own organization, kind of makes sense. And we can see, data being used in different ways. I often show off this one, if I spelled it right, the Toronto crime map. By the way, there's crime maps available for pretty much every city in North America. This just happens to be the one for the city of Toronto in Ontario. And again, we can look at all crime or crime by a particular type. Again, neighborhood crimes. And this uses ArcGIS and S3 data. Again, Python-based. So again, we can look at crimes. We can take a particular type of a crime, maybe an assault, and we can say, let's go from some particular date, let's say January 2020 till yesterday, and we can apply that. What will happen, of course, is it will take the data and update it. Now, this is just one of the ways, kind of like I was showing you a moment ago, that we can show data. This just happens to be with GIS information. But that doesn't really matter what data you want to work with and how you want to present it. That's entirely up to you and your organization. So here we can see, Toronto downtown area, Toronto Island. There's Billy Bishop Airport, and again, we can zoom in sort of on these various areas in downtown. There's Union Station. That's the train station. And if I click on this, it will give me information about the type of assault and when it was and some of the other details. So applying data today and visualizing data can be done in many, many ways. And this is, again, going back to what we were talking about with the capability of something like Python, having the ability to work. And now here in JavaScript, we are using that to create a front-end app to be able to look into the data in more detail. Again, if you did a search today for, I'll put that up just in case you're interested in it. If you did the same thing in Washington, or you did the same thing in Boston, Los Angeles, you would get a similar kind of crime map that's available. And that's simply because folks have put that information out there, made it freely available, whether it was a municipality, province, state, whatever, or federal information. So that's essentially that data.gov site and the CDC site is where I pulled down the Nebraska data specifically to look at it. And what I did is I actually went through the data. Notice that it came in originally as a CSV file. I looked at the data sets and I realized there was some problem with the data. It was all string data, but it's not, obviously. It's some cases numeric data, could be floating point values, could be others. So I used Spark to actually perform a job to read the data and infer a schema to the CSV table. And so you will see that it went actually through and figured out that, you know, the date field is actually a timestamp, not a string. Right? Other fields, right, are string or whatever, and of course it set those values up, as you can see there. So there's the actual schema that was created by inferring it. In other words, Spark is smart enough to look at the data on its own and figure out what data types should be applied when it comes to the data itself. If it needs to be tweaked, that's part of the EDA process, part of the ETL process that we've been mentioning that data scientists will spend some time working through. And again, that's what I've done here. I've basically taken that and applied those values to the fields that I'm interested in working from. And then from here, I simply took that schema and counted how many rows there were. So there were 303. Remember, this is days of the year. So not all 360, right? Because again, COVID didn't show up until sort of February, March timeframe. And this was not the last week. It was the 12th of, or sorry, the 16th of December. I then took that schema, made sure it was all proper, and I loaded the data in, selected out the two columns that I was interested in particular, and then I set about plotting that data. So the idea was to, again, import pandas, use my matplotlib to do the plotting, as well as a couple of other tools that are available for shaping the data. From here, I brought in the data and converted it so that I could, as I said, shape it. And then once I shaped it, I applied the two X and Y columns to the data set so that I could plot it out. And so what you see down here at the bottom is essentially the date, right, and the number of cases. And we could, of course, expand on that date, but you'll see here that it starts off sort of the end of February, and this was the 12th of December. So the death rate of folks in Nebraska between the start of the COVID epidemic and at least the sort of almost the end of last year. Again, why would we want to explore this? Well, we want to know about those kinds of trends and so on, right? And these are important pieces of information to understand. So again, plotting something like this, fairly easy, as you saw there, but it does take some understanding of the various pieces that can be brought in to highlight the information that we want to expose. In particular, understanding, in this case, where the data is in the data set that I've downloaded and how I can access it, right? How I can plot it in my example. All right, so that's kind of the idea of the visualization piece. We've talked a little bit about that already. We'll look at some more coming up with AWS shortly as we continue through here. Mentioned about algorithms earlier, so scikit-learn, all of those other sites where you might find algorithms. Not to say that there isn't algorithms for Java or C# or C++ or other languages. There are, but those were the ones I showed earlier. Same thing with the machine learning piece. I showed kind of both of those pieces from scikit-learn. You'll notice on the other side, though, nothing about that in the data engineering role. The data engineering role, we're talking about continuous integration and continuous development. Now, wait a minute. Why are we talking about continuous integration and continuous development? Well, you got to go back and think about this piece and this piece. And that is that they're writing code. And because they're writing code, we want to save that code, modify the code, make changes to it over time, maybe apply new thoughts to the coding that's being done, fixing bugs, all of those things, right? New development pipelines that we're working on that we need to bring back into our master release, all kinds of things like that. So it's more of a case of looking at sort of the software development lifecycle and applying that as a data engineer. And that's really where data engineers get into sort of more of this area, and it becomes more about understanding sort of the SL, and the SD part of SDLC, right? So the life cycle and the software development, and you can see here from design, testing, evolution, right through, everything has to be done sort of in that manner. Often we'll get into plotting that looks like this. This is the Wiki Commons page that sort of shows, that life cycle to deliver some kind of product in the end. And again, that's kind of what we're talking about. And there could be a number of different choices here for the types of products that we might use in the software development life cycle, from the process, at the beginning all the way to the end. If we think about the old ways of doing this with the waterfall method, right, we sort of plotted all of that out at the beginning. Today, that's not the case. We still do our BDD, behavior-driven development. That's the given, then, and when, right, or when and then, depending on which way you go about it. I'll give you an example of that. There's 4 scenarios for logging into a website. So we have to come up with the testing that could be done for those 4 scenarios. What are the 4 scenarios? First scenario, you successfully log in. So given that you successfully log in, when you click the OK button or the sign in button, you're taken to, right, then you're taken to a new page. What else could go wrong? Well, you could fail, right? So what happens when you fail? Well, you're either returned to the same page. So given that when you try to log in unsuccessfully, you get returned to the original login page. Okay, sounds okay. Another scenario around the same thing. Given, right, that when you log in, you fail, then you're taken to the registration page. Oh, okay. So we can come up with all kinds of scenarios around that. So BDD's been around for a long time, behavior-driven development. It's basically coming up with the user requirements, and then how do we check to make sure that what is set up in the user requirements is applied to the software. The other side of that today is agile development, and you've probably heard of that, where you work in scrums and you work in very small sets of projects moving forward. Smaller pieces of code as well. And there they do something called TDD, or test-driven development, where again, they're doing the test cases first so that they can then apply the code around it. So the data engineer still needs to have understandings of that. They need to know about Git or GitHub or Bitbucket or Subversion or some kind of Team Foundation server, some kind of a repository for their data, so that as changes are made, there is the ability to go backwards in time and pick up fixes if something goes wrong. They also have to have some kind of management tool. Today, Jenkins or something like that is quite popular. And then, of course, some kind of deployment stream that they're actually using to do so, whether it's on-prem or to the cloud. So there's a little bit more expectation on the data engineering side to know about specifics around the managing of things in repositories, the management of the life cycle of that software as it's developed. Also down below that, you're going to see that other piece that I mentioned earlier, and that's the data pipeline. Now there's a lot of ways to move data today. That is the role of the data engineer. whether it is receiving JSON files or Parquet files or CSV files or even SQL files, we need to move them in a manner that makes sense. We've got a lot of tools to do so. A lot of them are based on moving many pieces of data. Just to give you an example, in our building, we're doing 10,000 to 100,000 messages a second. Sounds like a lot. There's organizations like Visa that are doing a lot more. So we have to think about how can we move that data successfully without losing data. So one of the first things that comes up in the data pipeline is Kafka. Kafka is a queue, meaning that as the data goes in, it sits one after another in a long queue, and then we access it in the order that we received it. Also, because it can store data for a long period of time, minimum of 7 days, could be longer. If there was some kind of system going down, there's no opportunity for loss of any of that data, kind of like a transaction, right? If you think about how transactions work in SQL, you commit or you roll back, we don't lose data, it's kept in the logs. Same kind of idea here with Kafka and even Storm, although Kafka is a little more prevalent. The next one there is Scoop, that's moving data, and there's another one called Flume, allowing us to move data from SQL data stores in real time. Again, today, most databases have the ability of extracting data to JSON directly. You can write a query to do to JSON or JSON extract, and then push that data out. And the idea is that the data engineer needs to know how to be able to work with that data when it comes in, recognize the data, and then transform it in some way so that it can be stored on, which is the next part, some kind of server technology, whether it's on-prem or cloud. They really need to have that capability at this point, and they have to have a good understanding. And we're going to look at some of those pieces coming up. A couple of things I wanted to share with you. People start talking about, well, how much can I make doing this? And it's not really about, the money, I don't think. But if that's important to you, the lines are between about 120,000, and these are US dollars, to about 140,000 US dollars. If you're down there at the bottom where it says, Director of Data Science, something like that, it's going to be a little bit more, as you can see, but you can see the average, kind of the mid-level here. This average is where most either data scientists or data engineers fit into the organization. And this is from Insight, so it's actual real data from February of last year. Again, looking at a junior data scientist moving through the levels of the various areas. And again, data engineer, a little bit higher than what's shown here, probably about 20,000 more than the numbers being shown, simply because software engineering and so on comes into play. Okay, so there's not an expectation for the data scientist to know software engineering. They might have come from an actuary background or an economics background, something to do with math, or as we said earlier, could be computer science. Doesn't necessarily mean they are, but those are good at places to start at least. Okay, so what's next? Well, this is the pitch from WebAge. So just to put that up there for you about courses that are currently being offered. On the right-hand side, you've got the data engineering, which is available now. Data science is coming soon. There's of course background on that. What I will do is I will share that with you. In fact, I can share that link with you. So these two links are the links that are available. Oops. And again, those are the ones that would be important. And I can share this tool with you as well, so that you have it, and the data that's available here as well. So the syllabus itself is here on that, so you can look at that if you so desire. And I can bring it up for you. Here it is. So just talks about the program, some of the things that they're going to cover, expectations, what you should know minimum. Again, this is on the data engineering side, what you'll kind of work with. You can see that there's a number of areas covered there, and how that's covered as far as what you're going to learn. So Spark and data pipelines, because we got to move the data first, and using Spark is quite common. SQL and APIs. Again, this is looking at AWS, which I'm going to do in a moment, and we're going to take a look in particular at that. Again, around the services that we can run, like microservices, and then into data formatting. You can see cloud-based RDS, and then finally in week 3, data analytics. Now, that's not where it stops, though. There is an additional thing on EDA and ETL and so on, which is an optional week that you can take advantage of, and that's down here. The last one there is the one that I mentioned that you could spend a long time talking about, and that is security. So talking about that specifically here in the program. And again, that if you want to know more about that, just contact WebAge, because they're sponsoring this, obviously. Okay, what else can we talk about? Well, here's the big change, folks. There's been a huge linear climb in services today when it comes to the cloud. And you can see from this graph, this is over time, of course, but you can see that the leaders are listed there, AWS being the leader, followed by Microsoft, followed by Google Cloud Platform, and that's simply because of the time frames, right? If you think about what's happened recently, it's only been in the last sort of 6-7 years that Google's made their cloud platform available for everybody. Initially, they used it for themselves to run their own systems, but today that's being applied outside of that. And what I've done is a kind of a comparison of the platforms here, because I thought this would be useful. Again, depending on where you're coming from, you may be interested in saying, okay, yeah, we're not using Amazon right now, we're using Microsoft. So what's comparable between them, or vice versa? Maybe you're thinking about using Google Cloud Platform. How's that compared to AWS? I will say that throughout this one, we will concentrate, though, on web services with Amazon, so I'll show those off as far as this management learning session goes. So at the sort of basic or lowest level in AWS, we've got essentially what is a computer, a server, and we have what is known as EC2. Now, if you've never seen this, which is what we're here for, we're going to take a look at EC2 just quickly. So you'll notice this is the AWS Management Console. It's one of the ways in which I could access my AWS instances, as well as other services. And there's over 200 services today with AWS. Another way would be to use the AWS CLI, which I could here, which is the command line interface. And you'll see that I can basically work with various commands here at the command line. I'll show you a couple of those coming up. And we can look at information on our running system. So not only can I do it from the shell, or from, in this case, a command prompt in Windows, but I also have a visualization tool, which is the management console here, that allows me to do the same thing. AWS, to launch basically a machine, you come down here to the bottom, this orange button that says Launch Instance. At any one time, you will get information about the current resources. You'll see, at least in Oregon right now, there is nothing running here, but what we're going to do is go ahead and launch an instance. So I'm going to click on Launch Instance. I'm now presented with over 3,200 types of servers that I could run. Yes, I said 3,200 plus instances of servers that I could run. Or if I wanted to, I could upload my own as well. Now, that would be simply a VM that I would create, whether it's using Oracle or whether it's using VMware. I would basically create my own VM, upload it, and make it available to launch. There's a whole bunch of others in the marketplace in all kinds of different categories. There's also community available AMIs from a number of different vendors. You'll notice all Linux and Windows vendors are here, and of course 32-bit or 64-bit machines are available. I'm just going to go back to the quick start because that's the easiest way to do it, and I'm going to just pick something simple. You'll notice that there's an Amazon Linux version here that runs off an SSD. So let's just pick that one. I'm going to pick the 64-bit one. We could pick x86 or ARM, whatever your preference would be. I'll just go with kind of the defaults. And now I can come in and start to pick from the requirements that I'm going to have for the operation of the type of server I want to run. So this is where I have to think a little bit about, is it going to be memory intensive? Maybe I'm going to run Spark, right, in the cloud. Is it going to be disk intensive? Maybe I'm going to run an SQL server. And by the way, I could have picked a Windows server with SQL already installed on it. If I was doing that to cut down on the pricing, I'd bring my own license. In other words, I'd go to my vendor and grab the license, and then I would install it on the machine. Here, I don't need a license because it's open source in the case of Amazon, so it's just easier to show it with the Amazon Linux version. You'll notice the types are listed here. You can see it's by virtual CPUs and memory and the type of storage that we have to work with. EBS is known as elastic block storage. It's kind of like Lego. If I want to put that storage on this machine, I just plug it on. If I want to put it on a different machine, I unplug it from here and plug it into a new machine. Amazon's the only organization that does that. Microsoft and Google, you would have to reformat the disk in order to move it somewhere else or transfer it later at a cost. You'll notice that there's different sizings here, and you can see that it goes up to 8 CPUs and 32 gigs of memory. But Kevin, you said there were 512 gigs and more. Well, absolutely. That's going to depend on the type of instances that I'm looking at, and you can see that there's a number of types here available. So something that might be, memory intensive, which would be the M one there. I could go down and I could find those ones. And again, from here, you could pick the various types. So now you can see, there's 64, 256. We can get into GPU ones as well, which is going to be a lot more. And in fact, we could even sort this. Pardon me. There's 128, right? And notice the memory, that's in gigs. So again, lots of different choices that we could make. This is just a demo, I'm just going to choose the standard. I'll go ahead and configure it. What I would do here is I would add a VPC to my system. Now, to understand what that is, it's a container for all of my IP addresses that I would have for the machines that I want to run. So again, a VPC, I would pick the particular VPC that I want to run in, and then the subnets. Now you can create a VPC if you don't have one. It's as simple as that, and it will go out and assign you that IP address block for your machine to run in. And you can do that, give it a name. I'm just going to call this S1 WebAge. And I can set up the blocks, so 10.0.0.0/24. So that's a setting of CIDR, so basically IP addresses that I want to use. I don't want to go too far into some of that. I could have chosen IPv6 or something like that as well. And you'll notice I can give it a name. This just helps me find it later. So there, it's created a VPC for me. From that, I could also have my subnets, and I could create a bunch of subnets that are going to be part of that. Again, I'd map them to the one that I'm working with, and I'll call this S1 subnet, just to give you an example. Again, we would set out a block. Let's make it 16, something like that. Again, availability zone, let's make it in the West. This is in Oregon. That just happens to be where I've chosen. Amazon, as does Microsoft and Google, has these resources around the world that we can choose from, depending on where our clients or we are, or with regulatory information, we may have to put them in a particular country, right? So again, things that we consider for this. Whoops, oh, I didn't put one. Yeah, 0.0.124. Sorry, is that what we set up? I don't remember what I set up. What did I set up? Yeah, no, that's what I set up. Why is it not registering that? Okay, it's not required anyway for what I'm doing. I'm just showing you from here. But essentially, we would get our VPC, we would get our subnet, then we would add our storage to the system, and away we would go. This is the hard way of setting this up, essentially creating the instance. And again, we can assign those IP addresses or create our subnets based on what we need to do. So I think it's because I didn't hit go on the last one before I finished that. Yeah. So I didn't choose my subnet under this. That's all. And again, we would basically create those subnets, and we would then have those subnets associated with the particular VPC that we're using, right? So this one there we go. And once that's done, I would have an instance up and running. As I said, I'm not really too worried about showing all that, but the idea is back here, I would have my instance running. So that's the computer. I'm not going to use it, so I'm not going to show that, but I just want to make sure that you have an understanding about that. In order to do any of this, I have to have permissions set up. So what that's known as is identity and access management. So again, from a manager point of view, what you should know is that everybody has to have user accounts with roles and policies that allow them to do something. If I was to go and look at my user account, which is here, K Clements, then I could find out what I'm authorized to do. I have full authorization on this. That's because we're doing a demo, and I have to show you various things. But in the real world, we would probably limit what the individual user is allowed to do, and there's all kinds of policies that are available for all of the different services. Remember, I said there was over 200 different services that are available. This is where you would set up the service. So for instance, the next thing I'm going to show you is an S3 bucket. So in here, you'll see that there are pieces of information around S3. So I could have full access or read-only access to an S3 bucket depending on what I'm doing. So that's kind of the idea. What is an S3 bucket? It's essentially a file system. It's a file system where you're going to store files. So I've created some this morning just to give you sort of an idea of what this is about. I'm going to do one through essentially a script momentarily, so you can see that as well. But essentially, these buckets are where we store information. Now, before I go there, is there any questions about EC2 instances or virtual machines? Auto scaling is the idea that I can add more machines automatically within a range. Maybe I want 10 machines when it's very, very busy, like it's a website, and I want to scale that down to only 2 machines when it's not busy, right? So they'll automatically launch or ramp up. They call that scale out and scale in. Right? Batch, of course, means that you're running a batch file, a script, which we're going to see. VMware, as I mentioned, we can bring up our own. And parallel clusters, meaning that we have something like Hadoop where we want a bunch of clustered environment machines to run. The next slide is actually on some of the additional services. These fall under platform as a service. So the first ones was the infrastructure, the hardware. Then we get platform as a service. We get things like web services, as I was just mentioning. You'll see Elastic Beanstalk and Lightsail. Those are the two main ones on AWS. Microsoft has App Service and Google has App Engine. Then from a database perspective, as we were mentioning earlier, you might want your SQL database. Now, RDS by default sets up an SQL database. It's called Aurora. And what it does is it's similar to MySQL or Postgres. But that doesn't mean that that's the only one that you can set up. There are other available databases, so Oracle, Microsoft SQL Server, IBM DB2. You know, there's a long list of them that are available to be launched under RDS. On the Microsoft side, you'll notice that they only have their MS SQL, MySQL, and Postgres SQL, and Google has SQL Server, MySQL, and Postgres. So Amazon, you have a little bit more choices when it comes to the databases that you might want to run there. Below that, you're going to see something called DynamoDB. You're going to see SimpleDB, and you're going to see Amazon DocumentDB. These are all NoSQL type databases. Again, similar to, in the case of DynamoDB, it's similar to Cassandra. SimpleDB is similar to Redis, in-memory data store, which is key value pairs. And DocumentDB is similar to Mongo. Mongo and Cassandra you can get as applied databases in Amazon. The others don't support that, so you've got CosmoDB, you've got the specific ones when it comes to Google. And then down at the bottom, you've got Elastic Cache, which is again a version of a memcache, a memory cache. You get cache for Redis in Microsoft, and you've got Cloud Memory Store or Redis Enterprise Cloud on Google. Redis is also available directly on Amazon, just not listed there, but I wanted to have sort of comparisons so you'd be able to see that, and that's a good thing to be able to take away here from class. The last piece is the software as a service, and you'll notice that this gets into the word serverless, containers, container orchestration, those kinds of things. So we've got Lambda, which are essentially functions that run, that set up and provision stuff. We've got Elastic Container Services, which is like Docker, but on, again, Amazon in this case. You'll notice the equivalents on Google and on Microsoft, as I said earlier. Fargate is like Kubernetes, but it's Kubernetes and Cloud Container built together, whereas you can also run EKS, which you'll see down at the bottom. And Kubernetes is kind of like that scaling out and scaling in of servers, but it's done with a different technology because it works with Docker containers, not full-blown applications like an RDS or some other kind of server technology. And then you've got Service Fabric Mesh on Microsoft Azure. I teach that with C# actually. You got App Mesh here, and you've got Antheos, which is used on Google Cloud. So a bunch of different choices again that's there. Where I'm going is, of course, to the S3 piece because I want to talk about that, and that is next here. And that is this idea of object or archive and file storage. S3 is a hierarchical data store similar to Hadoop with, of course, Amazon brand around it that allows you to basically create folders for your files. You'll notice that if it's longer term and you want to store that with minimal access, but you still need to store your data longer term, maybe 5 years, 7 years with regulatory compliance, then you can go to S3 Glacier, which is going to be cheaper, and even cheaper, something called Deep Archive, which is available. Equivalents, blob storage on Microsoft. Of course, cloud storage in Google is where all of this started with the Google Big Table. So they've got their cloud storage and cloud storage for Firebase. And then cool storage, archival storage, as you can see in both Microsoft and cloud for Google. Finally, down there at the bottom, Elastic File System, Azure Files, File Store, as I said earlier, and Amazon WorkDocs, which you probably know would be similar to what Google Cloud does with Google Docs, right, or Google Drive. So very similar to OneDrive in Microsoft. Again, just familiarity with some of these pieces, and again, giving you feedback on that so that you have it going forward. Finally, here's the big data side. Redshift is a huge piece in Amazon. If you happen to be in the insurance or financial industries, Amazon today offers a larger piece for that called Snowflake, which is specific to financial and specific to other types of industries in that area. I didn't put it in here because it's still based on Redshift, but it's for specific industries. Pardon me. But again, if you are specifically interested in that, this is Amazon Snowflake. I'll put it in here because I do know that some of you have a background in that you might be interested. So here, again, sort of the idea that we were talking about. This is actually a good picture because we're going to pick up and use something very similar to this momentarily, and that is the ability to take data sources, do some extraction to them, store them in either a bucket like AWS S3, which is what I'm going to use, or we could use the enterprise data warehouse, which is essentially Redshift for the enterprise. And then you'll notice on the far right there, the ability to extract that information in some way, whether it's market or finance or data science, looking at the data. So this is kind of the AWS solution. We could replace this with RDS. We could replace this with only S3. Just again, going to depend on kind of the types of service that you want to run and utilize here in the cloud. But these are pretty typical of what we might see. So that's the big one, Redshift. There's a few others here mentioned, Elastic MapReduce, Glue, which we'll take a look at momentarily as well, which is essentially using something like Spark, as I showed you earlier, to take a look at the data coming in and infer a schema on the data. So we can actually do that and have AWS apply that for us. We don't have to think about what is this schema before we even start the process. We can start pushing our CSV files and have it build up a schema around the data that it receives. Again, this helps with furthering our efforts for data scientists to be able to look at that data in a quicker manner. Right? We can have it automated. A few others listed there as well for big data analysis, including MapReduce. Essentially, EMR is Hadoop and Hive on the web. QuickSight, which we are going to see momentarily, and again, that's just a reporting visualization tool. And then we've got Athena down here, which is an SQL engine that allows us to basically do SQL queries against our data. All right, so talked a little bit about this. Yeah, we could have, some boring tables, right? Pretty much. We could have other things as well available, but you probably don't want to do that. You probably want to have some nice visualization to it. I'll show you the boring table in a moment. All right, a couple of other tools today that are available. SageMaker is essentially Jupyter Notebooks, and I'll talk about Jupyter Notebooks in a moment again, that we can then do our scientific analysis in. You actually saw me do that in Jupyter Notebooks when I was showing off the Python pieces earlier. I just didn't tell you that this was essentially SageMaker or Jupyter Notebooks. This one is Jupyter Notebooks on Databricks. We're going to look at something similar to that momentarily when we get to AWS. So again, we'll see these different features and be able to look at them in of course, different ways. The big thing, of course, is to look at our data in the cloud. You can see that there's a lot of sort of machine learning and artificial intelligence tools, whether it is on Amazon or Azure or Google Cloud. All three of them support these different areas. really popular today, things like Lex and Poly. I teach courses in Elastic Search and Lucene and Solar, which are essentially natural languages using the natural language toolkits in order to understand what maybe you're writing or what you're saying to me. A few years ago, I was involved in a larger project in India where we were doing mentoring of students, and the idea the student could speak in one of 4 languages or write in one of 4 languages during the test, and the natural language toolkit in Python was able to figure out what they wrote without having intervention from a teacher or a mentor to look at that, and it could understand whether or not what they had written to answer a question was appropriate and grade them. So we have, these kinds of capabilities today with these kinds of tools that allow us to go beyond just, our simple tables, right, and do something with it, right? Data visualizations generally start with some kind of table data that we have, and we want to do something with that. We want to look at it in a different way, right? And so best way of doing that is to visualize it with some kind of chart today. They say a picture's worth 1,000 words. So in this case, it kind of makes sense to, bring that data to fruition and use it. So as it says in my next slide, let's take a look at some of these and give you sort of an idea of what AWS can do for us and what your data engineer and data science folks need to be able to utilize to do this successfully. Whether it's courses from WebAge or whether they're doing it somewhere else online. Maybe it's starting off with something like Udemy or Pluralsight. Again, those can be brought in with courses that we offer here as well as a complete package. Okay, this is an S3 bucket. What does an S3 bucket do? Well, it stores information. You can see I've got some CSV files here. In fact, I've got 4 of them. These actually come from the Northwinds database from Microsoft. I've got the customer table, the employee table, order details table, and the orders table. And what I want to do is be able to work with these 3 tables so that I can put them together and do a query. How might I do that? Well, the first part of that is actually getting them loaded here locally on the system. And that's actually pretty easy. You simply create a bucket. So we can create a bucket here. Let's call it Kevin bucket. Just put something on it. They have to be unique. I'm going to make it so I can access it, and I'm going to go ahead and create the bucket. There we go. That's how long it took to create a bucket. What do I do with a bucket? Well, I can put data in a bucket. What can I put in here? Well, you can pretty much upload anything that you want as far as files go. We saw the CSV files, so I could add a CSV file here. I've got some files for one of the labs, right? There's the 4 that you saw before. And back here, I've got some avocados. Let's play with the avocado one. And basically, I'm going to add that file to my bucket, so I can go ahead and upload it. There it is. And you can see that it's uploaded the CSV. If I click on CSV in the management console, it'll bring it up, shows me when it was loaded, talks a little bit about the the bucket properties here. If I wanted to see the data in that, I could look at the contents. It says right now it's a CSV file. But there is a better way to do that, and that's to use a different service. So back here, I'm going to take a service called Glue, and I'm going to create a crawler that's going to go through and bring in my table data. So remember, it's avocados. So here they are, the avocados table. Let me just open that so you can see it again, right? There's avocados, and it's actually here in the bucket where I can get it, or I can actually access it directly if I want. So I'm just going to copy this information. Okay. See, I've copied that information. I'm going to go back to Glue, and I'm going to go to the crawler. And I'm going to add a new crawler to go through my data. Now, what the heck am I doing? Well, what I'm doing is avocados. Did I spell that right? No. I always spell it wrong. Doesn't matter. Let's call it S1 just so I remember. All right. Notice that I can say it's in my data store and I want to crawl the folder that I'm going to give to my bucket here. So where is it stored, or is there a specific path? So I can include my specific path in my own account where that bucket is with avocados, right? Remember, what Glue is going to do is it's going to look at the data in the file. And what it's going to do with that data is basically try to display that data to me so that I can get a better understanding of the data, meaning that it has to extract the information and look at the types, the data types themselves. So the avocado file itself is essentially what I'm using here to do that extraction. And I'm using it in a way that allows me to work with the data itself and to get sort of an understanding of what's there. Now, to give you an idea before I start that, let me go ahead and open up the avocados file so you can see it. It has just opened somewhere on my machine. There we go. And there it is. Okay, so you can see we've got an ID field, we've got a date field, an average price, total volume, and a bunch of other information here, including the year and the region that the avocado was grown. And there's quite a few rows, right? Almost 18,000 rows of data. So it's not a small CSV file, but you know, it's small compared to other things, I suppose. So those are some of the fields that we have. Looks like ID is probably an integer. Date looks like definitely some kind of time value. Average price is certainly a floating point value. Volume looks like a floating point value. Could be, you know, larger int, I suppose, if we wanted. But now I'm going to go ahead and tell it to basically crawl that data for me. And to do so, I need to have the ability to do that. So I'm going to create, as part of my role, the ability, remember I talked about IAM earlier, the Identity Access Manager. I'm going to create a policy role that allows me to access this bucket. So that's essentially what's going on there. All right, and now we're going to go ahead and basically choose a database to put this into. So let's give it a name. Avocados. I always spell it wrong. All right, so we'll call it avocados. Perfect. Again, we could prefix the table and so on. Don't really care. I'm just going to go ahead and do that. So I've got my crawler, got my bucket, my role that allows me to do so. When do I want to run it? When I call it, basically. And what's it going to be stored as? Avocados. So I'm going to go ahead and say finish. All right, so you'll see that this crawler has been created. I'm going to click on this and I'm going to run it. But before I do that, I need to show you that that database, avocados, which is here, right, it has no tables. Okay, so you can see avocados, no tables. There's a log file, but that's associated with sample DB, right? So let's go back to our crawler. Let's go ahead and run our crawler. You'll notice that it takes a moment to do so. This was quite a large file. Again, we might have this process automated to run at certain times during the day. That would be more natural to do. Here, it has basically said that it's run the crawler. There we go, and it's now finished. Let's go back to our databases. There's avocados. Let's go look at our tables. So it looks like it's basically created it. It's got prepared for us, and again, we can go ahead and do something with it. So from there, what we would do, we could do a bunch of things. And you'll notice I mentioned about things being able to be set up and run at different times. Here in Glue, we can actually set jobs to be run. So as a data engineer, maybe I know that the data is prepared each night. available after 1 o'clock, 1 a.m., and I want to move that data so it's successfully moved up here the next morning for 7 a.m., right? So ideally, I could create a job that would do that. And I could add a job here that would basically set up the name of the job, the role, the type of job I want to run. Notice the difference. Spark streaming, Python shell, Spark jobs, who's going to do it, where is it going to be done, and of course, other advanced properties that I could create. So there is the ability to create jobs that can be done at any time, or jobs that are triggered at certain times. So I can create triggers that would do other things. Maybe once that data was successfully loaded up, right, I could then go and use it. I can also create a notebook similar to the notebook that we saw a few minutes ago on Databricks that would allow me to look at the data and run, queries against it in Python. We've already done that, so I won't go back and do that again. But again, same thing here. This actually uses SageMaker to create the notebook, as you can see, and then I have a Jupyter notebook that the data scientist would run against my data. So what else can we do here? Well, let's go back to our AWS services for a moment, and let's look at Athena. Now, Athena is a query engine that we can use to work with our data. And you'll notice that there's our avocados file that was brought in. Let's go ahead and preview that by running a query on it and see what gets returned. 0 rows. Well, the reason that there's 0 rows is we've created the table, but we haven't uploaded the data from the bucket. So even though we've got the information here in the structure, as you can see, we need to associate that structure, that data source, with our data. So again, we would come in here to our data source, and this would be where we would connect our data source so it basically has the capability of reading that. So here we would query the data in S3, set up a crawler, which we already have, or we could enter it manually. Again, we'll connect that. And this is where that crawler that we've created, right, already, we would use that. And there now you can see that, we've got our table ready, and we need to run the crawler that's down here to associate with that. So that's kind of the process. So you can run the crawler at different times to do different things. The last thing that we did with it was have it run and create the structure for the schema. Now it's going to run and essentially basically work with this data. If we then go back to Athena here, I didn't actually connect that, but if we go back to Athena, then we would be able to run our query and see the data. Again, I won't do that. We just don't have time. I've actually prepared some ahead of time to see that. So I've got a sample database here that I've created that's got some logs in it, and we can basically go ahead and sort of read from the log files. All right, so you can see some data here that's available. All right, just to show you the kind of the process. It would take a few minutes to go through that, but I want to concentrate on something else. The next piece that I want to show you means that we're going to flip from what we've been doing back to something here, and that is the command line in the console. And I'm going to go ahead and run some command lines here. Imagine that I want to do this by running a script. I don't want to have to worry about provisioning EC2 instances. I don't want to have to do anything with the S3 bucket manually like I just did by uploading the file and going through that. I don't want to manually do anything with Glue. I want to automate all that. So in other words, as the data scientist and the data engineer, I can apply a job here that will basically do all of this for me in real time when there is data. And that's another thing we could check for, as we mentioned earlier. So what kinds of things can we do? Well, again, from a manager's point of view, always good to know that they can automate stuff. So let's see what we can automate. I'm going to run a command that says, oh, let me make this a little bit larger so you are able to see it a little bit better. Let's try that. Maybe larger again. Yeah, let's apply that. Okay. So the command that I'm going to run says list the S3 bucket directory. That's all it's saying. So AWS S3 LS. I'm connecting out to my S3 and I'm going to look at these buckets. So I should have 3 when I'm done here that are displayed remotely. So I'm going to go ahead and run this command. And hopefully that'll connect. Why is that not connecting? Hang on a second. Yeah, okay. AWS S3 LS. All right, there we go. We've got our buckets. Oh yeah, the Kevin buckets there. That's right, I didn't refresh this screen. I have a couple of windows open. There we go. So there's the 4 buckets. There's actually 4 buckets there currently. All right, what I've done ahead of time is I've actually prepared a script. And essentially what this is Visual Studio Code. I've gone ahead and I've created in CDK a new project, and I can show you how to do that. And then I've basically, inside of the project, I've added in the pieces that I want to work with remotely. Again, data engineer, data scientists, both can do these kinds of things, and they can set up CDK. You can download the console development kit to be able to do this. There's also the SDK, which works with other languages like Python and TypeScript and Java and C# that you can run full programs in. This language that you're seeing on the screen is something known as TypeScript. It's very similar to JavaScript, just adds data types to JavaScript. In fact, the output that we would run is actually JavaScript here in the background. So CDK itself runs JavaScript, but we write in TypeScript. All right, so what can we see from this? Well, I'm importing some packages from Amazon. You can see there's a bunch of them here. I've downloaded my CLI, which we saw a moment ago, the command line interface here. And in doing so, I've installed things like Node, which is again a JavaScript tool. I've installed TypeScript and so on. And now what I've got is some import commands to bring in the various pieces to my project. These are modules that have been created ahead of time for me to run. Again, because I'm running in Node, these are Node modules, and I would look at them here if I wanted to. You can see there's a bunch of Node modules. There's probably about 3,600 or so there. And what I've gone and created here is simply the ability to import those modules and run some commands so that I can automate that process that we were talking about a moment ago. I want to upload a file to an S3 bucket. I want to essentially run a glue job, and then I want to read the file in Athena when I'm done to see what it looks like. Okay, so those are the processes that we would go through. I've installed my credentials on my machine for AWS to log in remotely and securely. And now I'm ready to deploy some files. The file itself is the sales pipeline file. We can look at it. You can see here it's some data, date, the salesperson, the lead, name, segment, region, and so on. That's of course coming from the header here across the top. It's essentially a CSV file, and I'm going to upload that to the cloud and then work with it. To do so, I'm going to create here what's essentially called a stack. Now, a stack is something that I can run over and over again, kind of like that job I mentioned a moment ago. And on AWS, when we talk about stacks, I'm just going to get back to my AWS console. There we go. What we're talking about is a technology known as CloudFormation. These are reusable pieces of code that we can call schedule, if we want, remotely, and utilize them to run through the process of moving that data and analyzing the data for us at some level. From there, we would then bring in QuickSight to look at it visually. So that's essentially what we're doing here. So the stack, what is this all about? Well, let's take a look. The first thing that I'm going to do in the stack is take an instance of it. In other words, using the CDK stack, I'm going to call mine CDK data project stack. And then I'm going to start creating some buckets. I'm going to create a bucket called the raw bucket. And with that bucket, notice it says S3 bucket, I'm going to upload my file. Now you saw me do that manually a few moments ago when I uploaded the avocados file. I had to create the bucket. I had to change a bunch of permissions and things like that. Then I had to upload the file. I can automate that whole process. I can also automate the process of going into the file and looking at the data types, creating a database and a table structure around the data that I want to work with. This is where the data types come into play from TypeScript. And as you can see, I'm setting some of them to be string type, others to be something else. Right? So the different data types that I might want to work with. And I can give the table an actual name, sales pipeline or whatever. I could also automate the last portion of that, which is it would open up and select the data. I just don't want to do that because I want to go through and show you that it actually did that and move the data, and you can see the data there. One other thing, because I'm interconnected here on my machine, and this would be the same thing for your engineers or your scientists, we can install a special piece called the AWS Explorer, the toolkit itself, that allows me to see information without having to type things on the command line. So notice those are the buckets that I created earlier. And if I open up the bucket, I can see the avocados file that was created 19 minutes ago. Right? So different ways of exploring. I could look for container services or lambdas. I could look for my cloud formation, which there are none right yet, but we're going to build one. So the next part of this then would be, how do we go about doing that? And that means going back and setting up things properly. So I'm going to go ahead and move into this folder where this project is. Whoops, not LS, which is called CDK project. So I'm going to CD into that folder. And I'm going to go ahead and tell CDK that I want to create a new stack. Notice it's a single command. It says CDK bootstrap. And I'm going to go ahead and run that command. Now what that's going to do is it's going to go out to the stack and it's going to provision a new stack name. It's going to provision a bucket for me to store my data in. And it's going to set up all of the permissions that are required for that, including for Glue. So I'm not having to do anything here other than run this very simple command to create that cloud formation, that stack, that I'll then run and have it provision the S3 buckets, the Glue job, Athena, anything else that I would require for this operation. Again, this is exactly what the data scientist would do or the data engineers would do to move the data from one location to another. You can see it says it's been successful. The next part is to then run this part of the application to go through and actually do the work. To do that, I need to deploy this script, basically. So I would say here, CDK deploy, and that will now take my script and start to run those pieces that we mentioned. So the first thing it needs to do, of course, is go out and build the bucket. Now we can see this if we want in real time. So just before I say yes to that, let's go see what's actually happened. Oh, look at that. So it basically created a new CDK toolkit here under the CloudFormation stack. If I go back to my S3 buckets, you should see that I've got a new staging bucket. That's where I'm going to basically send my data for my sales pipeline momentarily, and it will load that into the bucket for me. And then once that's loaded into that bucket, you'll see that there's nothing currently there. Then it will run the glue job against that bucket. Okay, so that's essentially what's going on. I just need to say, yes, go ahead and do that. You'll notice in here, it's actually provisioned a lot of that information for me and set up the roles and so on here in the file. So, following through that, oh, that's really hard to see. There we go. That's essentially what's been done. So I'll go ahead and say yes. Notice it says it's publishing, meaning that it's connecting and basically following through those provisioning jobs that need to be done for the bucket, for the file to be moved, right? Publishing there. And of course, creating the actual CloudFormation job that we will use momentarily. Remember, as I said, we could look at that information from here as well, right, as the buckets are being done and so on, or as the cloud stacks are being created. I would just have to do a refresh of that. But essentially, what's going on is it's creating that. So there, it's created a new stack project. Again, if I go back to my stack over here and I do a refresh, there you can see created and in progress, and you can see the time and date here is current. So it's actually creating that. And if I go back to my management console, eventually I should see something get loaded here. Yeah, there it is. So the assets are being created, right? That's what it just did. And it's starting to deploy the file right now. So it's actually using the Lambda file that I've created there, the CDK, to deploy this information. So it's got the assets, and under the assets there they are, the zip files, right? So it's sent them up as zip files, and those will be available. My CloudFormation stack is probably pretty much done by now. Doesn't take too long. Oh, not quite. Doesn't take too long generally to do all this. So remember, you saw me go through and set up a server. On that server, I would need to set up an S3 bucket associated with it. I would need to set up the glue job. I would need to set up the table names and all of that. This is all being done for me through this file that is running. In other words, the stack that is being used. And everything looks good so far. It looks like it's been creating these properly and managing to load my data. All right, that will take a few more moments to do it. In the meantime, there we go. Let's go back and check to see what it says here. It probably should say it's been done. Yep. And again, if I go back to my bucket, right, you can see that it's created a new raw bucket based on that naming that I had. It's given it a generic hash here on the end to make it unique. All buckets must be unique. And then the raw data, which we mentioned, and then finally the sales pipeline. So again, moved all of that up for us to make it available. If I go back to my data here in the data store in Athena, let's go back one level, right? We should see that there's a new database, my database, and I should see the sales pipeline is here. There it is, right? And again, I could work with it. In fact, I could even edit this if I want. Let's just take a look at that. So we could preview the table or show the table properties. We could make changes to the table itself if we wanted to. Let's not do that. Let's use it the way it is. So it's brought up that those items here, and let's go grab it because I've already got it available for me over here just to show you what's going on. We've got our sales pipeline. Let's go ahead and open it up. And there we go. So what would happen at this point is that data has been uploaded. It's in the folder. We're connected to it through, this is QuickSight, so similar to Tableau, or if you were to use Excel with Power Charting or Power Tables. And you can see that we can start presenting data in a visual manner. In fact, just to prove that, we're actually doing that, let's go ahead and add a new visual. There we go. And let's work with the, let's see, the salesperson. And do you want to choose, because salesperson is a person, let's choose some data. Forecasted monthly revenue. There's a good one. So let's bring in the forecasted monthly revenue. There we go. Oh, you don't like that chart? Well, again, we've got a bunch of different charts that we could choose from. Maybe you want a bar chart. Right? Maybe you want a thick bar chart. Right, so you can see the salesperson on the bottom, and of course the monthly revenue. So this is the forecasted monthly revenue for whatever those time frames were. All right, so combining that, now this is the data scientist, right, doing further analysis. Data engineer probably stopped at Athena and did the query just to make sure the data was there. Now the data scientist can take over. If you want to use Tableau, by the way, Tableau can directly connect to Athena as well and read that data if required. So there's lots of opportunities here when we're utilizing these pieces to be able to do something like deploy it, look at the buckets, look at the data that we were working with, whether we're doing that from the command line, or whether we're doing that here with our, our tools, our S3 buckets, or whatever. You kind of have to refresh this, or working with our, stacks. It's entirely up to us what we need to do. The idea today is that as a data engineer, and especially when I start working in the cloud, I need to have a good understanding of what's available. We've concentrated on AWS in this part of the management learning series. In the future, we'll obviously look at Google Cloud and we'll look at Microsoft Azure as well. But just to give you an idea of some of the things that we're capable of doing today, and of course the value in that is the fact that we can do it in a very, very quick manner, so that we have the ability to share out this with anybody that is wanting to utilize something like this for their application development, and doing it in a very quick manner, as we saw, can make life easier. Can be scheduled, right? So we can get faster performance from our systems as required, and we can ensure that over time these can be reused. And I think that's the biggest thing that we are getting here, is the ability to have reusable pieces, allowing us to work with this in a more natural manner, creating scripts, right? As opposed to having to do all of that manually, as you saw me do in the first case. I'm going to share with you, of course, the presentation, and do thank you for sticking around. I'll open up for questions either through the chat, or you can, I believe, use your mic as well. Let me just make sure that that's been set. Yeah. But if you do have a question, please go ahead and ask. I will always entertain that. You could also send an email to me if you want after the class. If there's some specific question you have around any of the subjects that we covered today, I'd invite you to do that as well. I've shared my email there as well. You can contact me through WebAge, who invited you to the seminar as well. So open the floor to questions. Other than that, that's my presentation for today. I hope you enjoyed it, and I want to thank you very much for being here. Any specific questions around some of the materials we covered today? A lot of material in a very short period of time. I can tell you that WebAge offers courses in these areas that can be done on half-day basis, can be done in an evening basis, can be done full days. It just depends on the requirements or what your team might need. No questions then? All right, well, I'll stick around, but again, thank you very much for coming in and listening to me talking today. It's been a pleasure to share with you really where things are heading. Certainly see an amalgamation of those roles coming together today. Data scientist, data engineer, along with the other folks in the teams. And this is something that we're seeing a lot happening out there in the real world. If it's not happening in your organization yet, it's a good opportunity